So example 3, we're trying to find the focus of a parabola, and we're looking at y equals negative 1/2 x squared minus x plus a half. So what we're going to do is we are going to solve, and we're going to use completing the square. So one thing I'm going to do first of all is to get rid of the fraction, and to do that what I'm going to do is I'm going to multiply everything by -2 because I want that x squared to be positive as well. So multiply everything by -2. So now I have -2y equals x squared plus 2x minus -2 times a half is 1. And so what we're going to do now is I'm going to solve by completing the square. And so I'm going to add 1 to both sides. So now I have -2y plus 1 equals x squared plus 2x. And then I'm going to add something here. I'm going to add something to this side as well. So remember, to complete the square, you divide the b in half, and then you square it. So I'm adding 1 to both sides. And so what we end up with now is -2y plus 2 equals x squared plus 2x plus 1, and that factors to x plus 1 to the square. And so now we're a little closer to the formula that we want. So what we want to do is let's factor out a -2 on the left side. So -2, and we get y minus 1 equals x plus 1 squared. So now let's look at the equation the equation that is close to this. And so what that's going to be is the x is squared. So x minus h squared equals 4p times y minus k. So just things are kind of rearranged. This is on this side, this is on this side here. But we do know what our h and k is. So let's figure out like our center, just to kind of get a little graph. Our center is at -1, +1. So -1, +1. And then we know that it is open down because it's negative and it's vertical, so it's going to go that way. So we need to find what P is. So what we're going to do is you just plug it in. You say 4P, right, this and this, equal to each other. 4P equals -2. Now to solve for P, you find that P is -1/2. So the focus is -1/2 from here, so it's right at this point, and so that is -1 and then +1/2. So -1/2 means it's open down, right? So that's why it's -1/2. That means it's below the vertex there, and so our focus is -1.5. So try this example. Find the focus of the parabola, again using completing the square. All right, so if you tried this out, you would find that the equation is 4 times x minus 1 equals y plus 3 raised to the square. So since the y is squared, we know that it's a sideways parabola. And so when you figure out p is 1, and the focus is 1 minus 3. So now let's use the reflective property of parabolas. A line is tangent to a parabola at a point on the parabola when the line intersects but does not cross the parabola at that point, so it only touches it. Tangent lines to parabolas have special properties related to the use of parabolas in constructing reflective surfaces. So the tangent line to a parabola at point P makes equal angles with the following two lines. The line passing through P and the focus and to the axis of the parabola. So notice here, these are the same angle, which means this is an isosceles triangle. That distance is the same. So we're going to use that property in order to help us find the equation of the tangent line. So find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. So let's graph this first of all. It's kind of helpful. What I'm going to do is I'm going to scale it just to kind of give us a little bit more space. And so I'm going to scale, this is 4, that's going to be 1, and then -1 here, and then 1 up here. So I know with the parabola y equals x squared, it's at 0, 0, right 1, up 1, here is the next point. So I know that is helpful for what we were trying to do. Then we're saying that the tangent line touches at 1, 1 here. So doing the best that I can to draw this line. It's probably not good. So let me try it again. So tangent to this line, so something like this. It's probably not the best picture. And so what we want to do is find the equation of the line. Now what we do know is that we have to find the focus first of all. And looking at the equation, what we have, let's see, so it's vertical, so the x is squared, so x squared equals 4py. And so we want to find our focus, and since we know there's no number in front, so 1 equals 4p divided by 4, we find that our focus is positive 1/4. So about right here. So, you know, this isn't the greatest picture, but that's okay, getting a general idea. Now we know, now it's not drawn to scale, so we know that those are parallel. They're congruent, they're the same exact distance. And so let's label this D2 and this one D1. And so what we do is that we're trying to find the distance here. Distance has to be positive, so we're going to take this top point, the focus, minus the bottom point. Now it could flip depending on which way the parabola is opened. It's always the top minus the bottom one. So D1 is going to be, the focus we know is 1/4 minus, this point here is 0, b. We want to figure out what this b is, the y-intercept, and that'll help us with our line. And then we'll find the slope later on, right? So that's how we get the equation of this line. So it's 1/4 minus whatever that intercept is, right? 0 to b is here, and then 1/4 we have this. So if we subtract it, so notice it'll be a negative value for b, then you're going to be adding it, and that'll be that distance D1. Now D2, what we're going to do is we're going to use a distance formula to find the distance between these 2 points here, from the parabola to the point touching here. So this is 1, 1. The focus is x is 0, y is 1/4. And so we're going to plug it into that distance formula. So D2 equals the square root of x1, right? x1 minus x2, and then squared plus y1 minus y2 squared. So the distance formula. And so this is going to be, let's all name this x1, y1, x2, y2. So this is going to be 1 minus 0 squared plus 1 minus 1/4 squared. And so we are going to get 1 squared plus 1 minus 1/4, that's going to be 3/4 squared. So this is 1 plus 9/16. And then this is end up going to be 16/16 plus 9. So this is going to be the square root of 25/16, which simplifies to 5/4. So that is D2. D2 is 5/4. So now, I hope you see, we're going to set D2 equal to D1 because we had said that D1 does equal D2 according to the definition here. So D1 we know is 1/4 minus b, so I'm just taking it here, and D2 is 5/4. So let's subtract 1/4 from both sides. So we get negative b equals 4/4, or b equals -1. Hey, look at that. B is -1. Now we need to find the slope, and so you can use the slope formula, and then so the slope is from this point, 0, -1, to, we're going to use 0, -1 to 1, 1. So y value is -1 minus 1 over 0 minus 1. And so this is going to be a -2 over -1, or a slope of 2. So therefore, we have our slope, we have our y-intercept, so the equation is y equals 2x minus 1. So try this example here. Find an equation of the line, the tangent line to the parabola y equals 3x squared at the point 1, 3. So trying this out, you should have gotten y equals 6x minus 3. And here is all the work for it. So hopefully you were able to try it out.